Hello everyone and welcome back to the channel. I'm Sam Asimuo, and today we are talking about one of the most important skills every project manager needs to understand: project scheduling. And I want to start with something very important. A project schedule is not simply a list of dates. If I tell you design finishes September the 10th, development finishes October the 15th, testing finishes October the 30th, go live is November the 5th, that may look like a schedule. But as a project manager, I immediately have questions. What has to happen before development can start? Can testing begin before development is completely finished? Who is responsible for each activity? What happens if design is delayed by 5 days? And most importantly, does that 5-day delay affect our go-live date? That is where real project scheduling begins. In this video, I'm going to explain scheduling fundamentals in a practical way. By the end, you should understand what a project schedule really is: activities, milestones and deliverables, dependencies, duration versus effort, leads and lags, critical path, float or slack, the schedule baseline, schedule monitoring and control, and some common scheduling mistakes project managers make. Let's get started. Section 1. What is a project schedule? A project schedule is essentially a time-based model of how the project will be delivered. It answers questions such as: what work needs to happen? In what sequence? How long will the work take? Who is responsible? What depends on what? And ultimately, when can we realistically complete the project? Notice that I said realistically. That's important. Anybody can put dates into Microsoft Project, Excel, Jira, Azure DevOps, Smartsheet, Monday.com, or another scheduling tool. The difficult part is determining whether those dates actually make sense. Imagine that we are implementing a new customer portal for a telecommunications company. Management says, "Sam, we need this system live by November the 30th. November the 30th is currently a target date. It doesn't automatically mean November the 30th is achievable. As the project manager, I need to work backwards and understand the work required to get there. Requirements, solution design, development, system integration testing, user acceptance testing, production readiness, deployment, go live. Now we are beginning to build a schedule." Section 2. Start with scope, not dates. One mistake I see project managers make is immediately opening Microsoft Project or Excel and entering dates. Don't start there. Start with the scope and the deliverables. Ask, what exactly are we delivering? Because if the scope isn't understood, your schedule won't be reliable. Let's use our customer portal example. Our high-level deliverables could be: requirements completed, solution design approved, development completed, integration completed, testing completed, business approval obtained, production deployment completed. Once we understand the deliverables, we can break them into activities. This connects directly with the work breakdown structure, the WBS. The WBS helps us break large deliverables into manageable pieces of work. Think about it this way: scope tells us what, schedule tells us when and in what order. These two must work together. Section 3. Activities, deliverables, and milestones. These terms are sometimes used interchangeably, but they are different. Let's make it simple. An activity is work that consumes time. Configure server, develop API, prepare test cases, conduct user acceptance testing, migrate customer data. These activities have durations. For example, develop API, 10 business days. A deliverable is an output produced by the project. An approved requirements document, a configured application, a completed test report, a production-ready system. A milestone represents an important point or event in the project. Normally, it has 0 duration. Requirements approved, design approved, UAT complete, go live. So if somebody tells me UAT complete, October the 15th, that's a milestone. But conduct UAT, October the 1st to October the 15th, that's an activity. Understanding this difference will make your schedules much cleaner. Section 4. Activity sequencing. Now we get into the heart of scheduling. Once we know the activities, we need to determine what happens first, what happens next, and what can happen simultaneously. This is called activity sequencing. Let's say we have A, requirements, B, solution design, C, development, D, testing, E, deployment. A simple sequence might be A to B to C to D to E, meaning requirements must finish before design. Design must finish before development. Development must finish before testing, and testing must finish before deployment. But real projects are rarely that simple. You may have infrastructure work happening while software development is happening. Security review might happen while testing is underway. Training material might be developed before the final solution is completely ready. So good scheduling isn't simply putting everything sequentially. It's identifying where activities must be sequential and where they can run in parallel. Section 5. Understanding dependencies. This is one of the most important concepts in scheduling. A dependency means one activity has a relationship with another activity. Let's look at the 4 common dependency relationships. Finish to start. This is the most common. Activity A must finish before activity B starts. For example, development must finish before system testing starts. That's finish to start. Start to start. Activity B can start once activity A starts. For example, let's say application development begins. Once development starts, the technical documentation team can also begin documenting the solution. They don't necessarily finish together. They simply have a relationship between their start dates. Finish to finish. Activity B cannot finish until activity A finishes. For example, you may be preparing a final implementation report while implementation is taking place. The report can start earlier, but it cannot be completed until implementation is finished. Start to finish. This is less common. Activity B cannot finish until activity A starts. A practical example could be a shift transition. The outgoing support team cannot finish its coverage until the incoming support team starts. Don't overcomplicate this. For most schedules, you'll primarily encounter finish to start, with some start to start and finish to finish relationships. Section 6. Duration versus effort. This is another area where people get confused. Let's say an engineer tells you, this activity requires 40 hours of work. Does that automatically mean the duration is 5 days? No. Effort and duration are different. Effort is the amount of work required. Duration is the amount of calendar or working time between the activity's start and finish. For example, a task requires 40 hours of effort. If one person works on it full-time for 8 hours per day, then theoretically, 40 divided by 8 equals 5 working days. But what if that engineer can only dedicate 4 hours per day because they're supporting another project? Now 40 divided by 4 equals 10 working days. Same effort, different duration. This is why resource availability matters when building your schedule. Section 7. Resource availability. Imagine you build a beautiful schedule showing database configuration, 5 days, API integration, 5 days, data migration, 5 days, and you schedule all 3 activities simultaneously. There's just one problem. The same engineer is assigned to all 3. Your schedule looks excellent on PowerPoint, but operationally it is impossible. This is why project managers must consider resource availability and resource calendars. Ask questions such as, is this resource available full-time? Are they supporting another project? Are there holidays during this period? Are there planned vacations? Is the vendor available? Are there environmental constraints? Do we need another team to approve something? A schedule without resource consideration is often just a wish list. Section 8. Leads and lags. Let's make these concepts very simple. Lag means introducing waiting time between activities. For example, we install concrete and need to wait 3 days before the next activity. That 3-day waiting period is lag. In IT, perhaps a security certificate is requested and normally takes 2 business days to become available. That waiting period could become a lag. Lead allows a successor activity to begin before the predecessor has completely finished. For example, testing is scheduled to start after development. But instead of waiting for the entire application to be developed, the testing team begins testing completed modules while development continues on the remaining modules. You're effectively overlapping activities. This can shorten the project duration. But be careful, Overlapping activities can also introduce risk and rework. Section 9. The critical path. Now let's discuss one of the most important scheduling concepts. The critical path. The critical path is the longest sequence of dependent activities that determines the shortest possible completion time for the project. Let me simplify that. Suppose we have this path: requirements, 5 days; design, 5 days; development, 15 days; testing, 10 days; deployment, 2 days; total, 37 days. Now imagine another parallel path: infrastructure setup, 5 days; server configuration, 5 days; security review, 5 days; total, 15 days. Our first path is 37 days. Our second path is 15 days. Assuming these paths converge before go-live, the 37-day path is likely controlling the project completion date. That's our critical path. If an activity on that critical path is delayed by 3 days, and there is no available float or corrective action, the project completion date could also move by 3 days. That's why project managers should know which activities are critical. Not every activity deserves the same level of attention. Section 10. Float or slack. Now imagine another activity called prepare training materials. It takes 5 days. According to the schedule, it could start September the 1st, but it doesn't actually need to be completed until September the 15th. That activity may have some flexibility. That flexibility is called float or slack. In simple terms, float tells you how much an activity can move without causing a particular schedule impact. An activity with significant float gives the project manager some flexibility. An activity with zero float deserves much closer attention because a delay could directly affect another key milestone or the project's completion date. This is why I always encourage project managers. Don't just look at whether a task is red, amber, or green. Understand its schedule impact. A 5-day delay on a non-critical activity may have little impact. A 1-day delay on a critical activity could affect your go-live. Section 11. Building a realistic schedule. So how do we actually put everything together? Let's use a simple process. Step 1. Understand the scope. Know what you're delivering. Step 2. Identify deliverables. What tangible outputs must the project produce? Step 3. Break deliverables into activities. What work is required to create those outputs? Step 4. Sequence activities. What comes first, what comes next, and what can happen in parallel? Step 5. Identify dependencies. Connect related activities. Step 6. Estimate effort and duration. Work with the people actually doing the work. Don't sit alone and guess. If a developer is responsible for an integration, involve that developer in estimating it. Step 7. Assign resources. Who is responsible, and are they actually available? Step 8. Identify milestones. Requirements approval, design approval, testing complete, business approval. Go live. Step 9. Calculate and review the critical path. Which sequence determines the project completion date? Step 10. Validate the schedule with the team. Ask, does this sequence make sense? Are these durations realistic? Are we missing dependencies? Are resources available? Are there vendor lead times? Are there approval timelines? Then refine the schedule. Section 12. The schedule baseline. Eventually, the schedule is reviewed and approved. At that point, we establish the schedule baseline. Think of the baseline as the approved version of the schedule that we use for performance comparison. For example, baseline go live, November the 30th, current forecast, December the 10th. Now I know we're forecasting approximately 10 days later than the approved schedule. Without a baseline, people can keep changing dates, and eventually nobody remembers what was originally committed. The baseline gives us a reference point, original plan versus current forecast versus actual performance. These should not be confused. Section 13. Monitoring the schedule. Building the schedule is only the beginning. A schedule is a living management tool. As project manager, you continuously update it. Let's say today is October the 1st. An activity was supposed to start September the 20th and finish September the 30th. But the team tells you we're only 70% complete and we need another 5 days. Don't simply change September the 30th to October the 5th and move on. Ask, why are we delayed? Is this activity on the critical path? What successor activities depend on it? Does this change our milestone? Can we recover the schedule? That is schedule management. Section 14. Schedule recovery, fast tracking and crashing. If the project is behind schedule, there are different techniques we can consider. Two common ones are fast tracking and crashing. Fast tracking means performing activities in parallel that were originally planned sequentially. Originally, development finishes, then testing starts. Fast-tracked, testing begins on completed components while development continues. This can save time, but it introduces risk. If development changes something that has already been tested, you may need rework. Crashing means adding resources or cost to shorten the schedule. For example, instead of one developer working on something for 10 days, perhaps we assign another qualified developer and reduce the duration. But crashing isn't magic. Adding 5 people to a 5-day activity doesn't automatically make it a 1-day activity. Some work simply cannot be divided efficiently, and additional resources usually mean additional cost. So the project manager must understand the trade-off between time, cost, scope, and risk. Section 15. Common scheduling mistakes. Let's finish with some mistakes I see regularly. Mistake 1. Building the schedule alone. Project managers coordinate estimates. We shouldn't invent them. Talk to your subject matter experts and your delivery teams. Mistake 2. Hard coding every date. Instead of connecting activities with dependencies, some schedules have manually entered dates everywhere. The problem is that when one activity changes, nothing downstream moves automatically. Use dependencies wherever appropriate. Mistake 3. Ignoring resource availability. A resource assigned to 5 simultaneous activities doesn't mean 5 activities will happen simultaneously. Mistake 4. No milestones. Leadership usually doesn't want to review 500 activities. They want to understand major decision points and deliverables. Build meaningful milestones. Mistake 5. Ignoring the critical path. Not every delayed activity threatens the project deadline. Understand which activities actually control your finish date. Mistake 6. Updating dates without explaining variance. If something moved from October the 10th to October the 25th, leadership will want to know why, what's the impact, and what's the recovery plan. Mistake 7. Creating an overly detailed schedule. A schedule containing thousands of micro-tasks can become impossible to maintain. The schedule needs enough detail to manage delivery without becoming administrative noise. Section 16. A practical example. Let's bring everything together. Imagine I'm managing a telecommunications network upgrade. Our major activities are requirements, 5 days. High-level design, 10 days. Hardware procurement, 20 days. At the same time, environment preparation, 10 days. Once hardware and the environment are ready, installation, 5 days. Configuration, 5 days. Integration testing, 10 days. User and operational acceptance, 5 days. Production deployment, 2 days. Now I can start asking meaningful questions. What happens if procurement is delayed? Can environment preparation continue? Can configuration begin on part of the environment? Can testing be prepared while installation is happening? Which activity determines our go-live date? That's the difference between simply having a schedule and actually managing a schedule. Section 17. What should a project manager be looking at every week? When I'm reviewing a project schedule, I don't just ask, are we on schedule? I want to understand, what was supposed to finish last week? Did it finish? What's supposed to start this week? Are the prerequisites ready? What are the next major milestones? Which critical path activities are approaching? Which dependencies are at risk? Are there resource constraints? Has anything changed our forecast completion date? That gives you a forward-looking view of the project. A good project manager isn't only reporting what happened yesterday. You're looking ahead and asking, what could prevent us from achieving tomorrow's milestone? Section 18. The key takeaway. If there's one thing I want you to remember from this video, it's this. Scheduling is not about putting dates against tasks. Scheduling is about understanding the logical relationship between scope, activities, resources, dependencies, duration, and milestones, so that you can determine when the project can realistically be delivered. Your scheduling tool can calculate dates, but the project manager must understand the logic behind those dates. That's where your value comes in. So that's our introduction to scheduling fundamentals. We covered activities and milestones, dependencies, duration versus effort, resource availability, lead and lag, critical path, float, schedule baselines, fast tracking, crashing, and schedule monitoring and control. If you're new to project management, don't worry about mastering everything immediately. Start by asking 4 questions whenever you look at a schedule. What needs to happen? In what order? How long will it take? What happens if something is delayed? If you can confidently answer those 4 questions, you're already beginning to think like a project manager. If you found this video helpful, please like the video, subscribe to the channel, and share it with someone who is learning project management. And in the next scheduling video, we can go deeper into the critical path method, where I'll show you step by step how to calculate the critical path, float, early start, early finish, late start, and late finish, using a real project example. Thank you for watching. I'll see you in the next video.